Hello everyone. My name is Dugley from Bloomberg. So today, thanks for inviting me. I will give a talk about the how we simplify the password management using the single sign-on and multi-factor authentication. So the title of this talk, as you can see here, is "What is my password?" Now, a bit about my background. So I graduated from USC, got my PhD 3 years ago from the same lab with a Professor Garcia. And then after that, I joined the identity and access control team at Bloomberg, and I work since then. Mostly, my work focus on Bloomberg single sign-on systems that it has been used by own customers and all employees in our company. The other part that I involve into to manage the access to the Bloomberg Unix machines by the engineers. Okay, so here's the agenda this talk today. Let's start with the overview of what is identity and access management. First is what is identity management. So identity basically is a fact about who or what a person or thing is. So as you can see here, it's not just about a person's, about you. It could be a machine or device. For example, like when you join UCI, right? The information about you, including name, first name, last name, birthday, all of this information will be collected by UCI and keep in the system. And also same thing for the devices. When there's a new servers or new mobile devices, all of the information like related to the device, like manufacturer, firmware, versions, etc., will need to be collected by the organizations. Identity management basically this combination of processes, the organizational structure, and technologies in order to keep track of the identity during its life cycle from the beginning to the end. So basically, from since you join the company and then you leave the company, and even after that. The next part of IAM is access management. So access management contains two portions. The first one is authentication. You really who you are, and the other one is authorization to prove that the user or entity have some permission, has some right to do something or to access some protected resources. So in order to do authentication and authorization, we also use different approaches. For authentication, usually we use something called authentication factor. So in here we can see three categories of authentication factor. First, what you know, password, even your date of birth or social security numbers depend on the context. And the next one is what you are, like something comes with you naturally, like the iris, a fingerprint, all of that. And the last thing is what you have. So for example, you can get some token using the SMS message. You get some smart card from the bank that can give you a random number every single time you want to log into the system. For the authorizations, mainly it depends on the policy of the organizations. Mostly it will be divided in coarse grain and fine grain, and depends on how the policy is applied. It will have different details for each of them. So having the combination of the identity and access management will help the on like when anyone use a system, like user, contractors, customers, partners, want to use a system, first their information has to be collected here using the different sources like human resource, contractor information, all of these, and the information about that identity will be collected, a name, permission, and things. And once user or device want to access a system, it need to go through access management, do authentication to prove them based on the management policy in here, then it can access some resources or do some certain actions based on the permission. So that is the overview of the identity and access management. So let's move on to the second part of this talk about the single sign-on. So what is the reason why we need to have a single sign-on? It starts with this question: how many accounts do you own? And as you can see nowadays, I think for every single website that out there, probably you have to create the account for each of them. And in one of the survey, on average, one computer user have over 90 online user accounts. So it means you have to remember all those 90 online user accounts, and you have to keep your password secure. So long time ago, we usually encourage user to have very complex password by substitute the characters to some weird characters. But in fact, looking at this, there's some rules there, and having rules mean it's pretty easy for computer to crack it. But as you can see, it's pretty hard for human to be able to remember that. So nowadays we have another approach that using a random combination of words. So you will have a longer password, harder to guess, and then you can use some technique like to use your imagination to be able to remember the password. So even with that technique, it's still very hard to remember, I don't know, hundreds of different passwords. So that's why people still usually use the same of password or very few passwords for different accounts. So it means that if one account is leaked, it can be the hint for attackers to use that against your other accounts. And that is for the user. For the developer, it's also hard for them to be able to develop the very secure login system. And you just want to spin up quickly a web page. You don't want to spend a lot of time on the login system. You just want to collect user and password and that's it. So that's why we come up with the idea of single sign-on, and actually it's not new. It's very old ideas in the early 1970, 1980. So the idea is here that the user can authenticate once and log into multiple and different platforms, and then user only need to remember and protect maybe one or very few passwords and accounts. And then developer, they can offload all the security management into a trusted third party. So there are few actors around this SSO concept. The first one is user identity, basically the user and information related to that user. The second one is authentication/identity provider. So that is the actor that will authenticate the user. And the last one is a service provider. It will use authentication by the identity provider and to determine whether allow the users to use the service or not. So as I said, the idea is already developed for a long time ago, and one of the first of its kind is named Kerberos. So Kerberos is developed by MIT, and the idea in here is that the user, when they need to use some services, they go to the KDC server, basically the authentication servers, and they will enter user and password there, and in exchange they will receive something called ticket, and they can use that ticket to go to the service and to identify themselves and use the service there. So as you can see here, the idea is very similar. When you go to the cinema, you pay money to get the ticket first. You don't pay at the entrance of the room. You pay beforehand and use that ticket to enter the cinema room. So this was developed a long time ago. It's okay, but with the development of technologies, it's not easy to extend and integrate it with the new technologies. especially in the era of the .com companies, people use web page and web browser good for that. So that's why in about 2000s, Oasis um, developed this something called security assertion markup language, SAML. So SAML is built on top of HTTP, and it uses XML as a way to format the message, and it supports passing metadata about the user. It uses the HTTP redirect in order to have the request and response passing between the identity and service providers. So if you use your UCI email account in order to log in Google application like Google Drive, for example, then I'm pretty sure that it uses SAML. So you can see here that Google just UCI about verifying your identity, and just use the SAML response to create your account and log into your account. So SAML work pretty well for the web browser, but now we come to a new era like the mobile applications. So for the mobile application, it doesn't work on web browser. So like SAML is not really good to be extended to support that. So that's why we have a new standard nowadays called OAuth 2.0. And I believe that most of you already know what it is, because most of you probably already see these kind of screens before, that the application asks you to sign in with the user, either Google or Facebook account, and allow it to have permission to read your information like your name, your email address, and all of that. So OAuth is built on top of a format named JSON Web Token. So basically, it's a JSON that have different portions about the message, and it can be encrypted based using base64. And you can see a string right here is very easy to embed it into HTTP request, in the header of HTTP request. So that's why OAuth nowadays is very, very popular. I'm not gonna go into the details of how the OAuth workflow works, but as you can see that we have the development of the single sign-on protocols to adapt the new changes of technologies. So so far so good. Single sign-on seem very helpful, like that have to protect both user and also like the application from leaking the username password. However, it caused a problem, and I think you guys already think about that. That is it created something called single point failure. So it means that nowadays, if someone able to compromise your single sign-on account, then they can use it to serious. If they can compromise the single sign-on server, then really they can be fake as anyone in the system. So recently there's an attack into the Microsoft identity management servers, the Exchange servers. So that's really like give people like see how serious an attack on the identity servers can be. In order to protect that, as I said, we have to protect at the server level and the user level. So for server level, I will not talk about that today, but for the user level, you can do something to protect your account. And that's why we come to the next topic in this talk. Is called MFA, multi-factor authentication. So probably all of you already use MFA already, because if you use like SMS token or email token, it means it's one representation of MFA. But let's go into the detail, the description of what is MFA. Probably all of you already use MFA anyway, in the form of like receiving token via phone or email. But today let's look into the detail, exactly the definition of MFA. So MFA, multi-factor authentication means that your security system should require more than one of authentication from independent category of credentials. As we said earlier in the talk, there are factors. For example, someone that user knows, something that user has, something that user is, and nowadays something about the user context. We need to be able to combine at least two of them in order to achieve MFA. So it's not necessary to be username and password plus something else. It could be your fingerprint and maybe your location, right? But still, it's very popular to use a username password and something else to create an MFA. And for the second one, we usually call that the second factor. Now, here are some examples of the second factor that you probably see. It could be a token device, it could be your phone. And here we have this picture of the second we as a company Bloomberg provide. So Bloomberg is very early adopter of MFA, considering our business is very sensitive. So we have to protect the user identity no matter what. So as you can see in the picture, we on the right hand side we have the device that I said before, what we call B unit. We use that to generate the token that user can log in. On the left hand side is the our Bloomberg keyboard. Is a very iconic keyboard, and the thing I want to tell you about today is that it has a fingerprint reader that can be used to log user into the system. So instead of having this, so I have a video here. Let me play that for you to give you a briefly idea about how we protect user identity here at Bloomberg.
Welcome to the Bloomberg, the total investment management tool, which lets you perform a vast array of analytical functions at the touch of a key.
When we started Bloomberg, we had one PC.
PCs were not yet as ubiquitous, obviously, as they are now.
So if we were to deliver our product, the Bloomberg product, we had to deliver the entire package.
We ran monstrous cables under people's floors, under raised computer floors, and we designed all custom hardware, from the ground up.
There was a fight for desk space, so hardware was a way to make a presence.
The screen, the keyboard, the communications lines, everything was delivered as one single unit on the person's desk, soup to nuts.
So as you can see in here, we sell our product as a package. So it is including both the software and the hardware, and the keyboard as a part of the system that we provide for the customer. So as you can see here, the keyboard has a very colorful layout with many new additional keys for various purposes. It helps to optimize the user workflow. And one important aspect of the keyboard that it actually a second factor device. So it allows the user to do the second check, the present checks by touching the device, and we have a fingerprint to do it there. Okay, so let's move on to the next step when it talk about the keyboard.
Everybody knows the iconic terminal. They know what it looks like. They've used it before. They've seen it. The keyboard is also
the face of Bloomberg on the customer desk. It established our presence, but more importantly, it provided the user with navigation through the Bloomberg system.
So we thought it was time to enhance the functionality of the keyboard in the B unit, to give it a different styling as well, and to give us new capabilities on the product side.
Hardware takes longer to build and to get it into production than software. There's a lot of planning and mistakes are very costly.
Our process starts with a management desire for, it could be as simple as something new. Generally, amongst ourselves, we'll talk about what technology we might be able to take advantage of.
We'll do multiple prototypes as we're developing the product.
We have 3D printers here that enable us to take what's called a CAD, a computer-aided design, and then translate that into a actual physical product that we can show to somebody.
They're very useful at the very first stages of designing something where you're not quite sure what the form of it should be.
Like all, Bloomberg projects, we talked to a lot of customers, and we got their feedback.
The good thing about Bloomberg users is that they're very opinionated. They don't hold back.
We hate the color, we hate the shape, we love the color, we love the shape, the keys are great, the keys we hate. All of these things.
They have this gut reaction. I love it, I hate it. And then we try and listen to their reasons and understand what their reasons are.
That makes actually, oddly enough, our job somewhat easier.
There were a couple goals we had in mind with this thing. We wanted to make something, very sort of next generation.
We essentially gave it a new brain, so it was able to do more with less parts.
We created a new security hardware architecture within the keyboard to improve our security posture even more.
We modified the biometric sensor so that it would be faster and work in more environments.
The swipe sensor works well for someone in a very cold environment and someone who's in Australia in the summer.
We create an abstraction of your fingerprint. We encrypt it.
So instead of just placing your finger down, you touch and hold it, and it reads a small image of the finger, our sensor can read basically the entire length of the finger.
The software that we run inside allows us to, for instance, detect when the fingerprint scanner is not operational and dispatch a message to the terminal for later diagnostics.
We also gave the B unit and the keyboard the ability to dock together. So that means that we have a wealth of new capabilities in terms of troubleshooting.
It also allows our customer support personnel to look inside an operating keyboard without actually disrupting the user.
The truth is, what's under the hood is quite complicated and very difficult indeed.
So as you can see from that, when we design the MFA device, we consider many factors, including how to make it secure, how make the fingerprint can read entirely of the customer finger, and also what happened in the Australian weather, the finger is wet, how the fingerprint reader can read that finger easily. So if you want to learn more about that keyboard, you can search that on the YouTube and watch it. So let's move on to the next content of the talk. So nowadays you don't really need to pay big money in order to own an MFA device. In fact, probably many of you already see that the many companies nowadays, including Google, Ubico, they already produce something called security keys. It happens to put an extra layer to help to protect your online accounts, so not only using the password. So it really help you to avoid phishing and many middle attacks, because you are the only one who can hold that device, and it also do the present checks. You have to touch the device when you do authentication to make sure that it's not the kind of replay attack or similar things. And this device can connect to your PC or laptop or mobile device through different method like USB or even now Bluetooth. And there's an organization today standardize all of these things in their FIDO. You can find about them on the internet. Look at that device, you might thought that you have to pay money to buy these security keys, but in fact, I believe you already own that in your mobile phone. So Apple, they pretty pioneer in this area, try to put a security chip in your phone. This is something we call secure enclave chip. On Apple device is called T2 chip. So these T2 chips will do anything related to security, including encrypt and decrypt, storing credentials. So when you first get your Mac devices or iPhone, what you need to do is you have to register your Touch ID's information, and this information will be only stored in the T2 device, and it has been encrypted. It cannot be read by anything other than the device. So that's why it makes the Apple device very secure. In fact, the idea of secure enclave chip has already created a long time ago in some server machine, and nowadays the Windows machine also have that too. It's just that it's not really popular idea that people know about until Apple they popularize it. So as I said before, you can use your mobile phone in order to verify yourself on the web. And how to do that? There's a new standard today called web authentication, or web authent for short. So basically, it's a standard API that allow browser to access a public key credential inside these security keys device, inside the secure enclave chip. And here's what it look like when your browser asking for the credential. So if you go to a website like GitHub that is protected using one of your key, so it will pop up this screen asking you to touch your device. So if you have a device like YubiKey, you can see it flashing, blinking, ask you to touch it. Or you also can be use the built-in sensor. Here it will read your touch ID sensor and verify your identity using your fingerprint. So all of these is built on the idea of asymmetric encryption. I believe that most of you already know about this in one of the security class. The idea in here that to encrypt and decrypt a text, we will use a key pair named public and private key. The public key will be published. Anyone can have that. And the private key is the only available for use, and you will be the one who signed the original text, and anyone can use the public key in order to verify that the content is created by you. So here is the flow of web authentication. For example, let's say you go to GitHub and you make a registration request. So you make a request to the GitHub, and GitHub servers will send back the app ID. Here could be github.com, and the challenge. The challenge will be a random number at the moment. Then via the browser, it will be sent to your authenticator. In this case, it could be your keys, it could be your touch ID, and the key will generate the key pair. And the private key, it will be only keep inside the hardware device, and because of that, no one can obtain it. And then the device will use this private key in order to sign the challenge, the incoming challenge, and then get some hash value and signature and send it back with the public key through the browser to the website. So the website here use that public key, use that the challenge that you sent it before to verify that the authenticator has been used to register with it, and then it will send back a successful registration back to the user. So for the authentication, it's pretty similar, the same, but rather than authenticate, it will use the authentication method to make sure that the device that registered to the website has been used. So having that, it comes to the end of my presentations. So what is the future of the identity and access management, and what is the future of MFA and single sign-on? So here are a few potentials, future development in this area, I think. The first one is using smartphone as a second factor authentication. So here, in fact, it's not about like using SMS as your second factor, because there are many research have pointed out that SMS is unsecure method as a second factor, because it's not that hard for people who can obtain your phone number or they interfere with your network in order to get the SMS token from you. Rather than that, the smartphone here could be used like using some authentication app from the phone, or using the secure encrypt chip on the phone. So with that, the phone, in fact, it can be act as the identity providers. So as I said before, identity provider keep information about you, like name, birthday, all of that. And nowadays we manage that like centralized. For example, UCI keep these information about you, right? But the smartphone, as long as can be used to authenticate yourself, it also can be used as an identity provider to provide these information. And especially now, the phone can keep many sensitive information, such as the your healthcare information. It could be very useful that you can use a smartphone whenever you visit a hospital, and the doctor just read it right there, and they don't need to keep it in their center system. Now, the last thing I want to talk in here is, um, as now everyone can own their own data in your devices, then this is something called decentralized and sovereign identity. So in order to make this work, I believe blockchain is a good candidate to make sure the authenticity of the data, and to allow everyone can verify the data that is belong to you. Okay, so that is the end of my talk. So here's my information. Probably not available for the live Q&A, but if you have any questions, please let me know. Send me emails to that email address. Thank you.